Alkanes are used as fuels, they are used as lubricants, and they are used as solvents. They are nonpolar, they are not water soluble, so this means that they don't do hydrogen bonding. They are soluble in organic solvents. The type of intermolecular forces between alkanes is the weakest, which is the London or the van der Waals forces. If you have a carbonate chain which is less than 5 carbons, these are gases. More than 5 carbons, more or equal than 5 carbons, these are liquids. Alkanes are not solids. They are either gases or they are liquids. Now, based on the nomenclature of alkanes, we said that alkanes are not functional groups. But based on the method that we use to name alkanes, we are going to name all other functional groups because all other functional groups are connected to alkanes. So this is why naming alkanes is very important because it sets the rule in order to name the other functional groups. Alkanes are not functional groups in there, so pay attention to that. The ending of the alkane is A and E. You do have this table over here. In this table, you can have it in the exam. You don't have to memorize it, but you need to know from carbon 1 to carbon number 20 how to name. So we're starting with methane, ethane. Guys, practice because you would need to know this by heart. So methane, ethane, propane, butane is 4 carbons, pentane is 5, hexane is 6. Notice that all of these alkanes, they end in A and E, which is a characteristic of an alkane. So you know that you have an alkane in there. There are 2 ways to name alkanes. IUPAC, common. Common, we use them for small alkanes. We can easily name them as common. IUPAC name, we use it for big alkanes and the branched alkanes in there. How do the name look like? The name looks like this. Okay, so you will be given an alkane chain. You will be asked, go ahead and name it. So to name it, first of all, you would need to know where are your substituents and where is your parent chain. So the parent chain is basically the longest carbonate chain. And you choose your longest carbonate chain possible, and that is going to be the parent chain. The parent chain normally goes at the end. You count its carbons in there, and over here the number of carbons are 1, 2, 3, 4, 5, and 6. So it's 6 carbons. You go over here, 6 carbon is a hexane, so your ending is going to be in the hexane. This is called the parent name. Parent name always goes at the end, and this is what you need to start with. Choose your longest carbonate chain, name it, put it at the end. Now after that comes what's on the chain. What's on the chain, we call them substituents. So over here, I do have a CH3 which is coming off the chain, so the CH3 is a substituent. I need to locate it, and the rule says that you would need to give the substituent the lowest number possible because you have 2 options to number. You can number either from the left or from the right. If you number from the left, this substituent will be on carbon number 3. If you number it from the right, it will be on 4. So definitely 3 is lower, so this is why you number it to give the substituent the lowest number. When you want to write the name together, you need to locate where the substituent is. This is why there should be a number before every single substituent. There should be a dash between them. And then the substituent and the parent name, they have to be connected with no space in there. Okay, so the name here is going to be 3-methyl and a hexane. Let's have another example. So my rule is to choose the longest carbonate chain possible. You start on one end. It doesn't matter. You can start from the right, start from the left here, or start from the right. It really doesn't matter. But I always like to start from the left. So I'm gonna start from the left, and I'm gonna move along the chain to get the maximum possible number. So see, when I reach here, I have 2 possibilities. Either going this way, which is going to add 2 more carbons to my chain, or going this way, which is going to add 3 more carbons to my chain. So I'm going to choose this way over here. Now here, notice that I do have 2 substituents. I have a CH3 and I have a CH2CH3 in there. Okay. Notice that when you name the substituent, instead, because this is connected to the main chain, instead of ending it in an A and E, you drop the A and E and put a YL. And this is a rule for the connection. When an alkane group is connected to a longer alkane, you name it as an alkyl. So you name it as an alkyl derivative, methyl, ethyl. So ethane turns to be an ethyl. Propane turns to be a propyl in there. Okay, I need to number to give my longest carbon chain to know how many carbons are there in my longest carbon chain. So I'm going to start by numbering on the side. I'm going to start numbering from here to give my first substituent the lowest number. This is 1, 2, 3, 4, 5, 6, and 7. So my name in there is going to end up being a heptane. So I put it at the end. And then now I need to number my substituents. So I do have on carbon number 2, I have a methyl group. And on carbon number 4, I have an ethyl group. I'm just going to write them like this. So this is an ethyl and this is a methyl in here. The ethyl and the methyl are different. So if this is the case, then I would need to arrange them in alphabetical order. And to arrange them in alphabetical order, I need to look at the M in the methyl and the E in the ethyl. Definitely the E comes first. So my name is going to be on carbon number 4. I do have an ethyl. Remember when I said every substituent need to be accompanied by a number? Where is it on the chain? So that is going to be 4 ethyl and then a dash. And then I'm going to have 2, a dash, and a methyl. No space, and then a heptane. Normally, the letter and the number are separated by a dash. This is always the case, and you arrange by alphabetical order. So let's see. Now, if the substituents are the same, then in this case, we're going to use the prefix di, tri, tetra. But guys, again, please remember, every substituent need to have a number. Substituents need always to get the lowest number possible. So start from the first substituent and always give it the lowest number in there. Let's have an example here. For this one, we're going to choose the longest carbon chain. And the longest carbon chain is not necessarily the straight chain. Because see, for this one, I can go simply this way. So I can go here. Okay, don't stop. I'm not going to go up here because this is 1 carbon. But if I continue, I'm going to end up getting more than 1 carbon there on the chain addition, I mean. So here you go. I'm just going to go ahead and continue. And this is going to be my longest carbon chain. So to choose the longest carbon chain, it's not necessarily always that you are going to start straight. No, it can be a zigzag in there. It doesn't matter. You keep moving until you get the maximum carbon number possible in there. Okay. Now, which end I need to number? If I start numbering from this end, my first substituent will be on carbon number 4. If I start numbering from this end over here, my first substituent will be on carbon number 1, 2, 3, 4, 5, and 6 in there. So definitely I need to start from here. So we're going to start from here. And this is going to be the number. Write the number down so that you won't lose a track. This is 6, this is 7, this is 8, this is 9, this is 10. Okay. So I have a chain of 13 carbons. So 13 carbons, you go into here, and 13 carbons is called a tridecane. So my ending is going to be a tridecane. Let's write it down. So I write the tridecane at the end. So now it's time to number the substituents. I need to number each one of these substituents. Let's highlight them. I have two CH3s, these are the same. So if they are the same, I need to use the prefix di, actually 3 of them. So I need to use the prefix tri, because tri is for 3. And then I do have a chain of 3 carbons here, which is a propyl group. So you look at the table, a chain of 3 carbons is a propane because it's an alkane substituent. You name it as an alkyl, so it's going to be a propyl. These are the prefixes here. Use di, tri, tetra, etc. whenever you have substituents that are the same. So over here, I do have a trimethyl. Okay, so this one is going to be a methyl. This one is a methyl. And this one is a methyl. And this one is a propyl. I'm going to group all the methyls together, but you have to make sure to put a number for each one of them. So, and if I want to arrange in alphabetical order, the M comes basically before the P. So I'm going to start the name by 4, 6, and 7 dash. You always put between the numbers comma, and between the number and the letter a dash. So that is going to be trimethyl. You cannot skip the tri, guys, because if you skip the tri, this means that you only have one CH3. You have 3 of them, and the 3 of them, they are not on the same carbon, so you have to number them where they are on the chain. So that's going to be 4, 6, 7 trimethyl. The tri doesn't go into the alphabetization. So whenever I am doing the alphabetization, I need to look at the M in the methyl. So always you skip the prefixes when you do the alphabetization. Pay attention to that. And my propyl in there on carbon number 8. So I have 8. That is going to be propyl. No space, and then a tridecane. So when I'm doing the alphabetization, I need to look at the M in the methyl, skip the tri because it's a prefix, and look at the P in the propyl. M comes before the P, so this is why I need to arrange these substituents like that in the name. Okay? Same thing over here. I'm going to choose my longest carbon chain. So I'm going to start from this end and move along. This 1, 2, 3, 4, 5, 6, go down 7, 8, 9, and then if I go this way, 10 and 11. 11 is undecane in the table. So that is going to be an undecane. And then now I'm going to go ahead and put my substituents. So my substituents over here, let's highlight them. I have a methyl, I have another methyl, I have another methyl, and then I have an ethyl here. Ethyl starts with an E, so I need to look at the E in the ethyl, and I need to look at the M in the methyl. I have 3 of them, so this is a trimethyl, but I'm going to skip the tri and look at the M in the methyl when I'm alphabetizing. Definitely the ethyl is the one that is going to be first in there. Now the question is, from where would I start numbering? Again, your first substituent needs to get the lowest possible number. If I start from this side, my first substituent will be on carbon number 4. But if I start from this side, I have 2 substituents, and both of them are going to be on carbon number 3. So I'm going to start from this side. It's going to be 1, 2, 3, 4, 5, 6, 7, 8. This is 9, this is 10, and that is 11. So again, every substituent needs to have a number. It doesn't matter if the substituents are on the same carbon. Every substituent needs to have a number. So here I have 2 methyls on carbon number 3. So I would need to put the 3, 3 in there just to indicate those methyls. So that's going to be 3, 3. I'm just writing it down, and then I'm going to put the name together. And then 6. You arrange the numbers from the lowest to the highest in there, and that is going to be trimethyl. Okay, it's going to be trimethyl in there. Again, M comes after the E. So on 8, I have an ethyl. On carbon number 8, I have an ethyl. So my name, let's put it together. It's going to be 8-ethyl. This goes first, then a dash. And then this whole thing, 3, 3, and a 6. And it's going to be trimethyl, no space. And then on decane, notice 3 substituents here, 3 numbers there. 1 substituent here, 1 number there. So the number of substituents needs to be matching the number that you are actually using, because this is what tells you where the substituent is. If you skip the number, then your naming will be not right. There are other rules if you have 3 or more substituents. If 2 substituents are found on the same end, like something like this. So I have here, see, if I start numbering from this side, this CH3 will be on carbon number 2. And if I start numbering from this side, the CH3 will be on carbon number 2. So which side am I starting to number? In this case, you want to give the second substituent the lowest number. So this is going to force you to simply start from here. So we're going to start here in the numbering. So that's going to be 1, 2, 3, and choose your longest carbon chain that's highlighted. This is 4, 5, 6, and 7. This is 4, this is 5, this is 6, and this is 7. And in this case, the name is going to be 236, because all of the CH3s are the same. So I'm just going to group them all together. And it's going to be trimethyl, and it's going to be heptane. Okay, now if both substituents are present on both ends, and those substituents are different. See, those substituents here were the same, so I skipped them and went to the second substituent and gave it the lowest number. But if these two are the same, what do I need? These two are different. What do I need to do? I need to go by alphabetical order. So the first alphabetical substituent is the one that is going to get the lowest number possible. This is going to be my longest carbon chain. And my longest carbon chain here is 6 carbons. So this is going to be hexane. Bromine, we're going to call this a bromo whenever we want to name it. And the chlorine, we're going to call this chloro whenever we want to name it. So whenever it's a substituent, it's going to be called the chloro, bromo. You have all the halogens, we're going to call them halos. So iodine will be called iodo, and fluorine will be called fluoro. There's a table in all of those at the end of the notes. You can also have that in the exam. So bromine, B comes before the C. So the bromine gets the lowest number, and this is why I need to number from the side. This is a 3, this is 4, 5, and 6. And I need to start from the bromine because the B is the first alphabetical order. So that is going to be on carbon number 2, I have a bromo. And then on carbon number 5, I have a chloro. No need for space. And then it's going to be hexane. Again, between the number and the letter, you do a dash. Between numbers, you put commas. There are some hydrocarbons that are named as common names, and these are small branched hydrocarbons, like for example the isopropyl group. So an isopropyl group is a group that has 2 CH3s connected to a carbon. Whenever you see this line in here, this means that this whole group is connected to a long carbonate chain. So this is the condensed structure for it. And there you have 2 CH3s connected to a carbon. This is called an isopropyl group. So iso is a simple structure which is made up of 2 CH3s connected to a CH. This is what an iso is. So if I ask you, Go ahead and draw isobutyl instead of isopropyl. Isobutyl is one more carbon. So you're going to keep that iso group. So keep that iso group and add simple carbon over here. And the structure will be called an isobutyl group. So again, an iso group is a group that has two CH3s connected to a carbon. So it has this structure in here, kind of like a Y. So this is called an iso group. Iso is part of the name. So whenever you want to alphabetize you have to look at the I. Okay. Now another group is tertiary. Tertiary is whenever you have three CH3s that are connected to a carbon. And here in this case, this one is called tertiary butyl. So it's a tertiary butyl because it is 4 carbons. And it's a carbon and the 3 carbons over here. So that is a 4 carbon. So you either name it as a tert butyl, same thing as tertiary. This is an abbreviation of the word tertiary instead of writing it down. So tertiary. We rarely write tertiary in there. Let me write it correctly. Okay, so this is tertiary. Butyl group in there, but instead of writing it as a whole, you simply write tert or you write a T and a dash. Tertiary is not part of the name. So when you are alphabetizing, you look at the B. Not part of the name, this is why we put a dash between the tertiary and the butyl. For the iso, we don't put a dash between them, so I is part of the name. And then the last one is the secondary. So secondary is simply whenever you have a connection on your second carbon to the longer chain. This is what a secondary is. So that carbon is a secondary carbon. Why it's a secondary carbon? It's a secondary carbon because it's connected to 2 carbons here. And the total number of carbons is 4. So I'm going to call this a secondary butyl group. Sec means secondary. So that is going to be a secondary butyl group there, and it's the same idea as the tertiary. You put a dash between the sec and the butyl. This means that the secondary is not part of the name. So when you alphabetize, you are going to look at the B in the butyl instead of the S in the secondary. Same thing over here. You look at the B in the butyl, but here you need to look at the I in the iso. Later on, when we talk about cyclo, C is part of the name. Well, we will talk about cyclic as we proceed. So let's have examples on these. Give the IUPAC name of the following. We're going to choose the longest carbon chain in there, and then we are going to circle the substituent. So see over here, I have a substituent which is a branched, and this one is an isopropyl. So this one is an isopropyl, this one is a methyl. I is part of the name. So if you arrange it in alphabetical order, isopropyl comes first. So if isopropyl comes first, I need to give it the lowest number since both they are on the same end. This is on carbon 3 and this is on carbon 3. So you start numbering from here. That is going to be 4, 5, 6, 7, 8, and 9. And the name is going to be 3 isopropyl, okay, and then 7 methyl, and since it is the 9 carbon chain, it is a none. Every time you want to choose the longest carbon chain, so after you choose the longest carbon chain, we want to make sure to give the substituents the lowest number. We don't care about alphabetizing them. We care about giving them the lowest number if they are more than 2 substituents. So over here, if I start numbering from this side, then my second substituent will be on carbon number 4. Versus if I start numbering from this side, because both of these substituents are on the same carbon in their number. So this is why I would need to give the second substituent the lowest number. So if I start numbering from this side, that substituent will be more than 4. So this is why I need to start numbering from here. And then we need to alphabetize. So you do have an ethyl, you have a methyl, and you have an isopropyl there. Your first one, if I put it in alphabetical order, then on carbon number 4, I do have an ethyl because E comes first, and then the isopropyl in there. So I have my 7 isopropyl. The E comes before the I. And then after this, the M for the methyl. So I have a 3 methyl. And then the name here is going to be nonane. Okay. Same thing in there. Choose your longest carbon chain and number the first substituent to give it the lowest number. So this is why I need to start numbering from here. Now my substituents are an ethyl group, 2 methyls here, an isopropyl, and a secondary butyl. See, all of those I would need to put them. Let's write them down so that we can check their alphabetical order. So this one is a secondary butyl. This one is an isopropyl. I is part of the name. The S in the secondary is not. So here I would need to look at the B in the butyl. I would need to look at the I in the iso. And then, of course, I do have my methyl groups in there. So I need to look at the M. And I have my ethyl. I need to look at the E. Let's highlight all of those. Arrange in alphabetical order. The butyl comes first. So that is going to be 7 sec-butyl. Okay, notice the YL is very important, telling me that all of those are substituents there. On carbon number 4, I have the ethyl because the E comes next. So that is going to be for ethyl. And then on carbon number 8, I do have my isopropyl in there. So that is going to be 8 isopropyl. And then on carbon number 6, but I have 2 methyls on 6. So I need to put 6,6, and that is going to be a dimethyl. And then the ending is going to be a decane for a 12 carbon chain. Let's have another example over here. Choose your longest carbon chain and start by numbering from the side to give the first substituent the lowest number. I have 2 substituents on carbon number 2, so I'm going to number from this side. Notice that I did not start my chain from this carbon because I have a carbon here. You can start either from this carbon or this carbon or this carbon. It really does not matter. As long as you have one of them included in the long carbon chain. This is an 8 carbon chain, so the ending is going to be octane at the end. And then I have over here my tertiary butyl, and I have my 2 methyls in there. T is not part of the name, so I need to look at the butyl, and that is going to be 4 tertiary butyl because butyl comes first. And then I do have on carbon 2, I have 2,2-dimethyl. So that is going to be 2,2-dimethyl and octane. Okay. If you have 2 routes for the carbon chain that gives the same carbons, okay, so let's say, for example, these 2 are the same. These 2 are the same structure. Over here, so these are the same structure. I have 2 routes in choosing the longest carbon chain. So I can simply go this way and choose the longest carbon chain. And if I do this, I'm going to end up having 2 substituents. Or instead of going this way, I can go this way and choose the longest, which is still 6. So with this one, I'm going to get 6 carbon chain. With this one, I'm going to get 6 carbon chain. These are 2 the same structures, guys, okay? You can either choose the longest carbon chain from here, or you can do it from there. And both routes will give me a 6 carbon parent chain. Which one should I choose? There's a rule, and the rule says that always you choose the longest carbon chain with the most substituents. So this means that this route is wrong. I cannot use it because I'm generating just one substituent. On the other hand, this one I need to use because I have two substituents in there. So this one is generating two substituents, and the name in this case is going to be 3-ethyl, 2-methyl, and hexane.